Today's lesson is on ratio tables. We can use different tables and charts to help us figure out the ratio of different problems. The problem at the top reads, to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? So in other words, I want to make cupcakes that have all the same shade icing. How much am I going to need in order to keep the color the same? I can start by drawing myself a table that will help me figure out how many drops compared to how many cups of icing I have. The problem again states that for every 6 drops of yellow food coloring, I'm going to have 1 cup of white icing. And in the question asks, if I have 5 cups of icing, how many drops of food coloring will I have? Well, if you want to think of it in terms of how do I get mathematically from 1 to 5, I multiply by 5. So if I do the same at the top, I can fill in my chart, and the answer would be 30. 30 what? 30 drops, because it is a story problem. And even though I'm considering it as a ratio, the answer to my problem would be 30 drops of food coloring to 5 cups of icing. The next example can be found on page 40 in your math book, way at the bottom, letter A. A patient receives 1 liter of IV fluids every 8 hours. At that rate, find how many hours it would take to receive 4 liters of IV fluid. So I'm going to make myself a chart to figure this out. I'm going to put fluids on the top, and I am going to put the time that it takes to give those fluids on the bottom. So for every 1 liter, it takes 8 hours. How long will it take to get 4 liters of fluid? Well, mathematically again, I can figure how can I get from 1 to 4? I can multiply it times 4. All right, how do I get from 8 to 4? I would do the same thing, timesing it by 2, which would mean then it would take 32 hours. So my answer would be written as 32 hours to receive, and notice this is a little bit different than just writing a number answer, 4 liters of fluid. In the next example, I have cans of corn that I bought for sale, 10 cans for $4. That is the rate. It's not a unit rate, but it's a rate. What if I want to know how much it would cost for 15 cans? I can set up a chart that shows that for every 10 cans, it costs me $4. There is no whole number that I can multiply by to get 15, by multiplying 10 to get 15. So one thing that I can consider doing is called scaling. I can scale back in order to move up. I can move the 10 to a 5 by dividing by 2. And now I can take the 5 and multiply that times 3 to get 15. So I'm going to do the same process at the bottom. Divide by 2, and I get 2, and then multiply by 3 to get 6. So my answer would be 15 cans for $6. Our final example today is found on page 42 in your book. On her vacation, Layla exchanged $50 American and received $60 in Canadian money. Use a ratio table to find out how many Canadian dollars she would receive for just 20 American dollars. Well, let's make our chart. And we're going to put down our Canada money on top. And we're going to put USA, American money, on the bottom. Completing our chart here, we've got $50 in American money is the same as $60 in Canadian, and we want to know how much Canadian money we would receive if we had 20 US dollars. Well, we can't go right away from 50 to 20, but what we could do is we could divide this first by 10 and get 5, and then go from 5 to 20, we could multiply by 4. So 2 steps to get to 20. On the top here, divide by 10, and we would get 6. Multiply by 4, and we would get 24. So what does that mean? For $20 of American money, we would receive $24 of Canadian money. I challenge you to do page 42, number 1, fill in the chart in regards to the ratio of allowance and the number of weeks that Santiago receives. The code for this lesson is Lions, the Detroit Lions.